Today we're going to start talking about types of angles and how to name angles, and hopefully a lot of what you're going to see today is review. We're just going to add a little bit onto it, but it'll be a shorter section than what we've covered earlier this week, so that'll be nice for you, a nice little relief. So first thing is I want to review the types of angles. We have acute angles, which are greater than 0 degrees and less than 90 degrees. Okay, so they have to be between 0 and 90. A right angle is exactly 90 degrees. And an obtuse angle is greater than 90 and less than 180. And then we have a straight angle, which is exactly 180. And so those are the four types of angles we're going to talk about. And then we also are going to talk about how to name angles. Okay, so we're going to talk about classifying them by acute, right, obtuse, or straight. And then we're also going to talk about how to name these angles. So the first way we can name an angle is just by the letter that is labeling the vertex. So this one could be called angle Q. Okay, that would be the easiest, most straightforward way. But we can also name it using 3 letters, which is necessary if there is more than one angle in a diagram or more than one angle formed right near the letter Q. So if we had like another line coming off of this angle, we would for sure need to use 3 letters. But the other ways we can name it is angle PQR or angle RQP. Because Q is at the vertex, it has to be in the middle when we name it using 3 letters, okay? This one, number 2, we can name a variety of different ways. Again, the easiest is going to be angle Y, okay? We could also call it angle 1 because there's a 1 in there this time. Or we could also name it using 3 letters. But again, that Y has to be in the middle or else it is incorrect, okay? So the vertex, the letter that is at the vertex has to be in the middle of the other 2 letters, okay, because that's the order. So it's like if you were to trace it, you could start at Z and go Z, Y, X, okay, and so it's Z, Y, X. All right, and then also naming this one, we can call it angle E, we can call it angle 2, we can call it angle F, E, D, or we can angle D, E, F, okay? So this is an example of why we need to use 3 letters when we're naming this. So this is angle LKN, so this big angle here. The reason we can't just call it angle K is because there's a number of different angles that we could be identifying. So we need those 3 letters to tell us that it's this larger angle here is 145, okay? So, and then we also know that LKM, so this part right here is 56 degrees. Okay, and we want to know what the measure of this is right here. And so this whole thing, though, is 145. 145. Okay, so to figure that out, we can do 145 minus 56, and that'll get the remaining angle, and that's going to give us 89. Okay, so 89 degrees is the measure of angle MKN. Okay, now let's look at this next one. You have to look at this or read that it is a straight angle, which means the entire thing is going to be equal to 180 degrees. So we know that if we add 10x minus 5 plus 4x plus 3, that is going to give us 180 degrees because it is a straight angle. Okay, and then we can use that to solve for x and then plug it back in to get the measures of those other 2 angles. So I'm going to combine like terms and get 14x minus 2 equals 180. And so 14x is 182, and so x is 13, okay? But that's not what the question is asking. We want to know what the measure of angle KLN is, and we know that KLN is 10x minus 5, so we would do 10 times 13 minus 5, which gives us 125, because 130 minus 5. So we know that the measure of angle KLN equals 125 degrees. Okay? We can also take that 13 and plug it in here, and so we know that that is going to be the angle measure of angle NLM. And that's going to give us 4x plus 3. So 4 times 13 plus 3, and that is 55, okay, because 4 times 13 is 52 plus 3 is 55. So the measure of angle NLM is 55 degrees. All right. All right. Now, for this one, we're not actually going to solve it. We're going to talk about a couple of things here. So it says, given that EFG is a right angle, set up an equation you could use to solve for x. So I just want to walk through. So this is angle EFH plus angle HFG is equal to angle EFG. Okay, this hopefully looks familiar. Okay, so I have two parts of a larger angle, and when you add them together, you're going to get the entire angle. Okay, so this right here, this is the angle addition postulate. Okay, we talked about postulate. Sorry, I can't spell today. We talked about the segment addition postulate on Monday, and how if you take two pieces of a segment and add them together, that's going to give you the entire segment, and you can just use that to solve for parts and pieces. Well, this is the angle addition postulate, which is exactly the same, just using angles. So if we have angle EFH plus angle HFG, we get the total angle EFG. So the two parts, the two smaller parts, make up the whole thing. So again, pretty straightforward. So we're going to do 2x plus 2, and that's this part. And then we're going to add x plus 1, which is this part. And then we know that this is a right angle, so it equals 90 degrees. So that part there, because we're told it's a right angle and it's marked. And so then we can combine like terms and get that 3x is equal to 87. And so we don't have to actually solve this. I'm not following my own directions, but we can solve it. Okay, so 87 divided by 3 is 29. So we know that x is equal to 29 degrees. That is the value of x that would make that a right angle. Okay. But again, the really important piece to get from this example is that that's the angle addition postulate. Okay. All right. One last thing today. So we talked about bisecting segments. We're going to also talk about bisecting angles. Okay, so bisect means to cut it exactly in half, whether we're talking about an angle, whether we're talking about a segment, it doesn't matter what we're talking about. If something is being bisected, that is going to be to cut exactly in half. Or in half. Exactly. Okay, so you're always going to have two equal pieces when you bisect something. We talked about that when we were talking about midpoints, okay? It means the same thing with an angle, though. So what it means is if BD, so this ray right here, bisects angle ABC, that means that angle ABD is congruent to angle DBC. Okay, so they are exactly the same. So then I can use that to solve for x. So 3x plus 6 is equal then to 7x minus 18. And so I can take 3x away from both sides. 4x minus 18 equals 6. And if we add 18 to both sides, we get 4x is 24. And divide by 4, so we get that x is equal to 6. Okay, so that means that the value, if we plug in 6 for x, that both of these angles should be equal. So we can actually check that. We can say, oh, is it equal when I do 3 times 6 plus 6? Because that should be equal to 7 times 6 minus 18. Okay, well, 3 times 6 is 18 plus 6 is 24. That's what we should get over here. So 7 times 6 is 42. 42 minus 18 is also 24. That's exactly what we should get. They should be equal because it is being bisected. Okay, so that means that both of those angles are 24 degrees. And that's what should happen if you have solved for your value, your missing value correctly. Okay, and so when bisect means to cut exactly in half. All right, please let me know if you have any questions. Have a great day.